We always we're always fixing errors and other problems. It will continue encountering. Although in other languages it will be a lot lesser, unlike C, because C is prone to errors. Other languages may have lesser errors, but would have like errors that would take you a lot of time to fix. So, Franklin, welcome, Mr. T. I have not heard your voice. I hope all is well. Okay, let me see. We'll drop that. Okay, Franklin. Franklin, do you have any question? This is an interactive session. We're not going to be dealing with any concepts. You already have reached the first deadline of the printed project, so we want to help you solve problems that you may have currently.
I don't really have any questions for now, but I just want to gain from wherever is going on right now. At least if I can get any clues on what to do next.
Oh, okay. That's fine. That's fine. That is the same thing that Shafi has said as well. Okay, it's first of all, it's great that you guys don't have any question. That means your project is currently going smooth, or maybe you're even done.
Actually, on my own team, it seems my partner has done pretty much everything. So I just need to try and understand what he's doing to
Oh,
get
okay.
more idea of the projects.
Well, you guys can pair program, and he can show you how he arrived at the solution that he has arrived.
Yeah, and in fact, we even have different approaches to the problem. That's actually another thing. We are using very different approaches, so I still need to understand those methods very well.
Okay, there's no problem. You can always reach out to your partner. I'm sure he'll be willing to do that, especially if the project is over. Jackson, you are welcome. William, you're welcome. Either of you have any problem, you can always unmute your mic and feel free to bring forth the problem. Let's look at it together. It's okay if you guys don't have any problem, but I wish you do. So we can tackle something. We may not even be able to fix it. I doubt that, but solving problems in C is quite fun. You can also ask me about anything ahead in the program. I am in my no in my second to last month, so I am your senior colleague. Feel free to ask any question that you may want to know about. Unless, of course, you're already a big time developer and do not have any question, that's still fine. But if you do have any question about printf or about any point in the program ahead of now, feel free to ask. An interactive session, guys. Please kindly talk to me. There's a lot going on in front, actually. If you really learn C, Python will be a little bit easier. I'm not saying Python is easy, it will be a little bit easier to learn. Python on its own is very difficult. The difference between Python, a low-level language, and a higher-level language the difference between C, which is a low-level language, and higher-level languages like Python or JavaScript is that C has very little things that you need to take care of. Like C has very little things that you need to know to be able to write C and like go very far. Very little. But Python and JavaScript have like a lot of things you need to know. Like you can't even know all of them. You'll constantly be browsing and researching to get some. It might be something very simple. It might be one very weird array method that you have just forgotten, but you know about. So you have to check. You have to browse it to be able to do it or use it. So guys, please bring your C problems, concepts you do not understand, errors you are struggling with, and stuff like that.
I just remembered something now. Maybe we can
Okay.
discuss that. And it's about function pointers.
Okay. What about them?
Okay, yeah. If you remember, I don't know if you can still remember the function pointer task from month one.
Oh, I will not be able to
Is
remember
there any
that
way I can
actually.
just
Oh,
like
go on.
okay, it's like a calculator task. We have to create a function that takes a function that takes three parameters: the first number, an operator, and the second number. Then
Yes.
something there was something we did in that project. We used the operator string to we used function pointers. Then we used the operation strings in a structure. Do you
Yes.
understand? So we created a
Yes.
structure, and the structure was like it takes a character which defines the operator and the function pointer to the
Yes.
function that operates on the numbers, right?
Yes.
So I was trying to do something similar to this printf project. I was thinking if there was a way I could create a structure where it stores the specifier as a character and a function pointer to a function that deals with that specifier.
That's exactly what you should do.
Yeah,
Literally.
because before that I was trying to use switch statements,
No, okay.
and I
Yeah.
realized that the more cases I add to the switch block, it's going to
Exactly.
be too long for the function.
Exactly.
And I couldn't think of any other way to break it into
That is exactly
one.
how I did my printf. The first session that I held, I used switch statements because we were just going to handle three specifiers. But I
Yes,
made mention that you have to use function pointers because there are lots of specifiers and you don't want to clog the printf file with too many specifiers, with too
yes,
many cases. So using function pointers is very great. So you just have, like you said, you have the character. So when it matches that character, it calls the function that you assign to that function pointer that
yeah.
handles that character. That's just
But
it.
that's not exactly where I'm having issues now because
Okay.
the idea is simple, just a structure that stores the specifier and the function pointer. But in my
Yes.
case, all the functions I've been creating, like for so far, I've created like four different functions.
Yes.
But those
But
four
what?
functions are not really similar. You know, in the calculator projects,
Yes.
the calculator project, the four operators are taking in two parameters.
Yes.
So you can easily define a structure which is going to return a function pointer to a function that takes two parameters. It's that simple, right?
Yeah.
But in a case where I have different functions taking in different types of
Different number of
parameters,
years.
exactly different number of parameters and different types of parameters, how do I create such a structure?
Just give me a second. Anthony,
Hello.
yeah.
Yeah, sorry, I'm very sorry for joining in late. I had technical issues on my end. I
Okay.
could not get my mic to work with my system, so I'm using two devices here. I'm really sorry to all the members of the meeting. I should be the host here. I'm very sorry. I apologize.
There's no problem. You're welcome.
Okay, so I'll be using two devices. If you notice, one of them will be for the audio, and then I'll be sharing my screen on one.
Okay, that's fine.
Okay, okay. So I don't know where. Okay, so
So the only question, this is the first question that has come in.
okay.
Franklin is asking that he wants In the calculator project that was done where we used function pointers, you know,
Okay.
it was easy to create the function pointers or the structure rather, because we
Okay.
knew that we just wanted one character and then two arguments. But now we
Okay.
are dealing with printf that the characters, the arguments would, it's a variable number of arguments. So he's asking, how are we going to arrive at that? How
Okay.
structure are we going to create to arrive at
Okay.
that?
Okay. I think I understand the question. Okay. So Franklin, you are not too sure about how the structure for the printf functions will look like, right?
Yeah.
Okay, because it's supposed to be each function should be accepting maybe multiple arguments, right?
Yes.
Okay, so let me create a header file here on my terminal. Can everyone see my screen?
Yes, the screen is visible.
Okay, okay, okay. So now the printf is basically a periodic function, and you know that each function you use in your printf might be accepting multiple texts or multiple strings. How do I put it now? It start with the percentage sign. So we percent s, some percent c, some might be percent and some other things before the s or the c. Is that clear?
Mhm.
Does that make sense?
Yeah, yeah, it makes sense.
Okay, so you want to create a structure that will work regardless of the function you are using for your printf, whether it's a function that will be handling strings or a function that will be handling characters. And the best type of structure for that is a structure that will account for the variadic list itself. That's the var list itself. Do you understand what I'm saying?
Yes.
Okay, so let's see. We want to create a structure. Okay, so I'm going to create a struct, and in that struct, we'll be having both the name of each specifier and the function that will be handling that particular specifier. It won't be a function, it will be a function pointer.
Yep.
Hello, can you hear me? Okay, so I'll call that struct specifier, and let's say it will contain two items, a character, which will be what we used to know whether we are handling a string or a character or a digit. And let's just call that C for now, for testing purposes. And here we declare a function pointer. That's the function pointer that will point to the function that will handle the specific printf specifier we want to work with. So that particular function pointer, you know that when we're working in printf, what we're just doing is basically printing out strings. Though we might be accepting integers or accepting hexadecimal values, but we're just printing out strings at the end of the day. Does that make sense?
Yes.
Is that part clear?
Yes.
So we just need a function that returns strings and takes in variadic arguments. So we can call that f. We can call that function f, which returns a string and takes in a variable number of arguments, which is valid. This is how we declare variable number of arguments. Let me just make a few corrections here. Does everyone understand this function pointer I just declared?
Okay, I think I understand what you're trying to do here.
Exactly. So this is a structure that tells you that contains both the character that will tell you about the specifier you want to work with, and then the function that handles that particular specifier. And that function takes in the var list itself and returns a string, which is what you're just going to print out to the standard output. Because at the end of the day, everything we print out are just strings. We don't print out integers, it's strings. Everything is always converted to a string. Do you understand that point, Franklin? Franklin, was it?
Can I add
Yeah.
some?
So, okay, I'm listening.
Okay, I think this particular problem I'm having, it would be
Okay,
easier if I give more context, like
okay, okay,
kind of code I'm trying to write here.
okay. We can hear. I'm listening.
Is it possible for me to just share my screen or just show you the screenshot or anything?
Okay, excuse me. Yeah, if you can share your screen, that would be nice, so we can see exactly what it is you want to do.
Okay. So let me
Okay.
just quickly set it up so I can show you as well.
By the way, Jackson was asking, how do I solve more than 40 lines in a function?
Oh, okay. Jackson, are you still there?
Yes, it's on the call. Yeah.
Jackson.
Yes, yes,
Yeah. Okay. So you have a function that spans more than 40 lines.
yes, yes.
Okay. So the best way to do to solve such problems is you split in your
Mm-hmm.
function to do into two or more parts.
Mm-hmm.
Maybe you have a function that is supposed to, okay, let's for example a function that works with the specifier d. Now the function first of
Mm-hmm.
all takes in the variable arguments, yes,
Mm-hmm.
and then maybe you want to
Yes.
count how many digits and your number that was received,
Mm-hmm.
and then you want to find a way to convert those numbers into characters. Abi, does that make
Okay.
sense? Are you does my thought process? Hello?
Um,
Yeah, so you want to split in those are three separate tasks. You do not want to have every single one of them inside a single function. Hello, Jackson, do you follow?
Okay, continue. I'm listening. I'm listening to you.
Okay, yes. So those are three separate tasks, and the programming principles usually states that you want to have a single function that does one thing and does only one thing. So if you have a function that seems to be doing more than one thing at a time, you want to split in those tasks into separate functions and then call all of them within each other so that they can work together. That's how you solve such 40 lines, because that's the whole reason for 40 lines in a function. If you don't want a function that is so long and to be unreadable when you want to debug, that's the whole argument for 40 lines in a function. I hope I've been able to answer your
Okay, okay.
question.
Thank you. Thank you. Thank you.
Okay,
Thank you.
you're welcome. Franklin, have you been able to find a way to share your screen?
yes, I've set it up now. I was just trying to reset my comment history because my partner has done
Okay.
most of the work, so I just want to reset back to where I was having the issue.
Oh, okay, okay, no problem. I will be seeing that. If there's any other person who has a query, you can also always leave it in the chat section, so we can answer them while we wait for Franklin to share his screen.
Can you see it now? I'm ready now, so I can just.
Okay, okay. Let me see. Okay, I think I can see your Vim. I think
Yeah, I'm
new
in
Vim.
main.h now. The main.h
Okay,
file.
okay, I can see that.
So these are the kind of functions I have. This function handles characters. This one handles strings. This one handles digit of any base, and this one handles hexadecimal.
Okay, okay, I think I understand what you're saying.
Yeah, you can
Okay,
see that they
so
have very different
different
parameters.
arguments.
Yeah.
So what you do in this case is this. You remember that you can still see the struct I just declared on the screen, right?
Yes. I'll check this
Yes.
now.
So these functions you have, you can just create a wrapper function around these ones you have already. I don't know if
Okay.
you understand if you understand what I mean by wrapper function. Basically, a function that will call these other ones you've made already.
Okay.
But that wrapper function will now be in the form of this one containing this my struct here, so that
Yeah.
all of them can have the same form.
Hmm.
You understand what I'm saying?
Yes.
So
Yes.
it makes it easier for you to organize your code. So instead of having multiple functions, having different arguments and different return values, you just have a particular way each function is structured so that each one can just be called with maybe a for loop or whatever without having to have a very long switch case statement.
Okay.
Yes. So do you understand does that, will you be able to apply that to your project now?
I'll
Has that
try
answered
to.
your question?
I'll try to do more research on that because
Okay, no problem.
that wrapper is something else. Okay.
You
Thank
said?
you. So I'll try to do more research on using the wrapper function. Maybe wrapper will be like using function pointers.
Wait, okay. Can you show up that your screen again? Let me just see if I can show you how an example of Java function would look like
Okay.
with this same header file. So I'm just going to type in this thing, please. I won't create a new file, so you can just see as I'm working with it. Okay, for example, you have your print char function, right?
Yes.
Okay, so let's, for example, let's call our function print char wrapper.
Okay.
You see that it's returning a string,
Yeah.
okay, and it's going to be taking a var list. Let's call our var list args. Now, in this function now, we call in the normal way we call in periodic arguments, where we use var stats, and we call in the first, we use var stats. Okay, we know you don't use var stats here because you must have called var stats previously. So here you're just passing in the var list, which you must have already initialized after calling var stats. Okay, let me start. Let me see if I can get it from the beginning. Now we have a printf function like this. This is just going to be a very, very basic printf function. A very basic printf periodic function. This is how the printf function looks like. Now you call in var stats, which takes in two arguments, which is the first known format, and then the name of your var list. Let's call our var list args, but I've not declared it yet, so I'll declare it up here. Do you follow what I'm doing here?
I'm following.
Okay, but you notice I didn't include any header files. I just want to make it as simple as possible.
Yeah, I just want to
Okay.
understand the
Yeah,
structure.
exactly. So this is var list. I just create a variable called var list, which will contain the args.
Okay.
Now we call in var start here, and then you probably need a for loop that will be going through your format specifier. Maybe let's just say I equals to 0, and until your format specifier is still a value, not equal to null or something like that. Yeah. Oh, sorry, null string, null character, and I plus plus. So let's say we encounter a percentage character. Format I is equals to %. Now here we want to extract the arguments that the person has called. Right? If you see a percentage character, I want to know what kind of specifier that the person must have called. If it was a percentage C or a percentage S or percentage D, right?
Yeah.
Exactly. Now here we'll call in the var arg function. So let's assume we have another function that takes in the next string, the next character after the percentage sign. So we check the specifier. We check format I plus 1. So this function now will now check if the specifier that is after percentage sign is a C or an S or a D. Now, for example, let's just abstract away this function and just put the return value somewhere here, which should just be a character. Let's just call the character SPE. We just abstract the whole function again. We don't declare it yet. We just say it returns a character, which will tell you whether it's this character or a string or a decimal you want to work with. And now you get that return value. So that return value is what you will now use to index through your specifiers and find out through this struct, that's this struct I declared here,
Yes.
and find out if the SPE matches with one of the characters in that your struct. So
Okay.
you might have maybe an array of that struct. Let's call this struct spec funcs, spec fn. And in my case, maybe it's an array of those functions, of those specifiers. Give me a second. Okay, so you declared, you called out, let's just call it all specifiers. And then in that array, you have each of the character accompanied by the function that handles it. So for example, if you have a C character, you have maybe a function that handles char, handle underscore char. You have a D character, you have a function that handles decimal. You have I is the same thing as D, so just handle decimal will work for it too. And then you want something like maybe a blank string, so you tell you that you're at the end of your array, so you don't have any function to go through again. So you see that this array I declared is an array of pointers of what do you call it now? An array of the structs. Exactly. Thank you for that. It's an array of the structs. And you see that every of that structs must have the same pattern. If not, this array won't be declared properly. So they must have the same type of function pointer and the same type of character. They must be characters too. So you have a character and a function pointer of the same type. So now let's call this, okay, instead of calling this handle char, let's call it print char wrapper here, since we are calling this wrapper function here. So now you come to your print char wrapper here, and then let me see your header file. Can I see is your screen still sharing?
I just removed it now. I'll share it back now.
Okay, let's just say you have your function called handle char.
Can you see it now?
Okay, so you call your function print char.
Yes.
So inside this print char wrapper, we'll call in that your print char you have initially created, and then we pass in the value from the var list. So we come here and create an argument. Since we know that we're getting a character, we'll create a character argument and a variable called char args or arg, anyone you wish. And then you use the var arg function to extract that character from your var list. Do you understand what I'm saying?
Yes.
Okay, so when you extract this, there should be two arguments here. There should be an int here, two arguments. Usually, I like to what do you call it, cast it into a chart type so that you don't have some kind of overflow errors. But that's optional. So you have this. You have now extracted the variable argument from the var list, which is called args. Now you can call your print char function, which takes in a character. Your print char function takes in a character, right?
Yeah.
So here you call in your print char function with that arg that you just extracted. So you can just follow this same pattern for every other of your functions. Just create a wrapper function which will take in the var list, and then call your regular function to handle the particular argument that has been extracted.
Okay.
Does it make sense to you now?
Okay.
That
So
explains
from what I've explained now,
Okay.
I'm thinking the best solution would be to refactor my code entirely, because I'm seeing some issues with this solution as well.
Okay, you're seeing some issues that will affect your code base, right?
Yes. For example, now this wrapper function, is only going to work if my function only takes something from the var lists, right?
Okay.
For example, this function here, print base digits, it takes in a number and a base. And in my function, this number is supplied from var lists like you did here.
It's come up in var list, yes.
Yes, but base is not supplied from var list. It's supplied after, like, for example, if I want to do hex, I would have to supply base 16. But that is not going to come from the var list itself.
Okay, then you can just make this print base digits some kind of helper function that won't actually print it. It will just return those digits for you.
Okay.
You can just call it with other functions that will now do the actual printing. So you abstract away the ones that will do the work, and then you abstract away the ones that will do the printing. So they won't be together.
Oh, yeah, that's what I was thinking.
You understand? Exactly. That's it.
instead of having one print-based function for all different bases, I can just do
Basis.
functions for separate bases, and it can
Yeah,
still use
exactly.
this method.
So you just have one function that will be doing the conversion for you, and then you have the different functions that will be printing depending on the specifier.
Okay, okay, makes sense now.
Yes,
Thank you.
exactly. Yes. Okay, no problem.
You said your teammate had already like done a lot, right?
Yeah, he has done most of everything. I don't even know how he's doing it. I just need to understand what he did.
Well, there's if you have any problem, like your teammate does not want to do pair programming or something, and you still want to try,
Okay.
you can obviously create your own repo. Don't call it the same
Yeah,
printf.
yeah, yeah.
You can call it any other name other than underscore printf, and then you can go ahead and try by yourself in your own
What I'm
repo.
even trying to do now is I actually created a separate branch for this one I'm showing you now. So
Yes,
I plan on doing it myself using this branch so I can understand the
exactly,
project properly.
exactly.
Yeah. So thank you. I really appreciate the explanation.
Okay, you're welcome, Franklin. Is there any other person who has a question or a query or an inquiry, anything at all that
We
you think
have
we can help with?
Kudus is a new member of this call. Kudus,
Okay.
do you have any question?
Your jumbo shrimp tasted better. How did you do it?
Insurance.
We still have about 25 minutes
Okay.
and handle as much questions as. Oh, T, you want to speak? I see you
No,
on mute.
that's me actually. No, that's
Oh,
me. That's my second device. Yeah.
all right, all right.
Jackson, do you have any question you want to ask? You know, any query or anything at all that I might be able to put you through? Okay, go ahead,
Yes,
Mr.
yes.
Kudus.
Okay, yeah, good evening.
Okay, good evening.
Yes, the question I want to ask actually is I want to know how people call functions into their programs because I just wrote my code like I didn't think of how to call functions. I don't know, but I'm seeing something on this screen currently that is displayed. I'm seeing people passing var list as arguments, but I don't really know anything about it. I'm just like curious on how one can just if there's any example I
Eh,
can
eh.
just use to have an idea about it to just like
About calling functions.
yes yeah in printf like how someone can
Like,
Okay,
you
so you just
calling
created
one function
functions.
to another one.
hello what is it
You mean calling one function into another one?
no to be sincere, I don't know how
Mm-hmm.
yes calling functions basically to not actually make the printf function have everything.
Eh,
I'm seeing this var list
Mr. Jackson,
facts.
can you mute your mic?
Nikiita selector inapeleka hii format.
Jackson,
Sasa iko kwa percentage ina add one.
wait, I think I can mute that mic. Give me a second.
Oh, okay, thank you very much.
Ask to mute. Okay, Mr. Kudus, you can continue.
Okay, like I'm seeing like on screen now, I'm seeing this person's code. I'm saying that he passed var list as an argument. So this is new to me actually. I've not seen something like this before. So
You don't know var list?
no, I know var list. I know. I just
Okay.
declare it every time I want to use it in the printf function. So like in the program, I didn't know like I can call it as an argument and
Okay, Anthony, you are calling
Okay,
var list objects
as an
in
argument.
your print char wrapper. Yes, that's what he's trying to say.
Oh, okay. So you are it's kind of confusing for you. Is that what you're trying to say, Mr. Kudus?
yes, precisely.
Oh, okay. Okay, so basically, a val is just basically a data type,
Yep.
and
Okay.
just about any data type can be passed into functions. Just like you can pass in your integer, your character, your pointers, even structures can be
Or
passed into as
even a
arguments to
structure that you
functions.
created. Exactly.
Yes, even exactly. Even a structure can be passed as an argument, although it's preferable to pass in a pointer to the structure. But even structures can be passed in as arguments to functions.
Okay. Okay.
And just about every data type can also be returned as a return value from a function, including the void data type. So as long as it is valid data type in C, it can always be passed as its argument and it can be returned as a parameter as a return type. Yes.
Okay.
So you
Okay.
said in your code base you just created functions. You don't really call functions. Functions don't really communicate to each other. If I got you correctly.
Yes, I just wrote basically like my single printf file is more
Okay.
than 40 lines. So
Okay.
I just wrote everything, like for each of the cases I was just using if else if for each
Okay.
of
Wait,
the
and some
specifiers.
character cases. Okay. Okay. But you're trying to refactor your code so yeah you can be using multiple
Yes, I
functions
was
instead
just
of if else
confused
if else.
whereby like I didn't know how I could be using that bag macro in such a way whereby I don't know. I was just like I didn't just have an idea of how I can just like but seeing this person's code now is already giving me hints
It's
An insight.
actually the
yeah,
speaker's
it's already giving me insights now. Maybe I will
Yeah.
look
Okay.
it
Just
and I'll look my
so
code and
basically, this code is just a code I just tried to run through right now for Mr. Franklin. I was trying to explain something for Mr. Franklin. So let me
okay.
see if I can just do a quick recap for you.
Okay,
Okay.
okay,
Okay.
okay.
So you can see on line 16, there's the I declared the printf function
Yes,
where
I
it
can see.
just has two arguments. It just has the format and shows that it's a periodic function.
Yes,
Now you can see the next line I declared args, which is basically a periodic list, which will store our periodic arguments. And
okay.
you can see the regular var start, which is how you initialize your var list variable with the format and the args. That part makes sense, right?
Yes, yes, yes.
Okay, so now this is the part where you start the abstraction. So you start, okay, I think I even made a mistake here. This should be fmt, not format, but I was just running through, so I didn't really look at that properly. So you
Okay.
start looking through your character. You know your string is basically what holds both the regular strings you want to print and your format specifier. It's just basically a whole big, very large string.
Yes, yes.
Yes, exactly. So you want to look through that string until you get to the end of that string, which is basically the null character, which is why you see in my for loop, there's a place where I check that the next item is not a null character.
Yes, yes.
You can see that in the for loop. Good. So
Yes.
now we look to that string, and if we discover that we see a percentage sign, we know that the next character might be a format specifier,
Yes,
right?
yes. Yes.
Now, this is the part where you start abstracting those functions away, where you start using multiple functions to be able to handle the workload. Now, if I get your code correctly, this is the part where you start using multiple if else and else if in your own code.
Yeah, yeah. Yeah.
Exactly. So instead of that, you can now create a function that I call check sp.
Yeah.
Check sp. Now, this function is what will now check if the next character is actually a valid format specifier. I just abstracted it away, but I'm just trying to give you an idea of what that function does.
Yes,
It
yes.
basically checks if the next character after percentage is a valid format specifier.
Yes, yes,
All
yes.
right. Now,
Yeah.
if it's find out that that character is a valid format specifier, it will do a particular thing. In this case, I just said to return a character, but that was because I was trying to explain wrapper functions to Mr. Jackson. But if
Yes.
you actually wanted to return it properly, it will return some sort of struct for you, something like a
Okay.
struct.
Okay.
Exactly. So that struct is what will now handle the format specifier that you were passed in.
Okay.
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 So
Okay.
let me see if I can just write something basic for that check sp. So basically, you have maybe a check sp function. Yeah. Okay. Let me just put char for this is a placeholder, but let me just write in the actual function here. So it takes in a character C, which is going to be the next character after your percentage sign. Yes. So you probably maybe you have something like a variable of all possible characters, of all possible specifiers, sorry. Maybe
Okay.
that variable will be looking like something like this. It will hold maybe C, uh D, something like this, C, maybe D, then I. Just basically all the valid format specifiers that are in your printf that your printf can handle. That's what this variable will hold.
Okay.
Yes. So now when you call your check sp function, it will just probably maybe we'll just loop through this all C array. Let's maybe declare a variable called I, int I equals to 0. For I equals to 0, let me just declare a for loop real quick. I all underscore ci is not null. I plus plus. So I'm just going to declare a for loop that will go through that character array that I declared up there and
Okay.
see if the character that was passed in to our function is a valid format specifier.
Okay.
So if C is equals to all underscore ci,
Ah, yes.
yes, exactly. So we return maybe we just return let's just return C back. Let's just abstraction. It might not be like this, it might not implement it this way, but let's just abstract it this way that it just return C back. So you know that yes, this is a valid format specifier.
Yes, yes.
And then if the for loop runs from the beginning to the end and it does not return any character, you just return your null bytes.
Okay.
And then in your printf function, if you see if this character here, if you will now check this SPE here and see if it is actually a valid specifier or it is a null byte. So you can just use if SPE here, or let me just make it more explicit. If SPE is not equals to null bytes, now you now check what SPE is, and then you call a specific function to handle that SPE.
Okay.
I don't know if that make sense up to that
Sure,
point.
sure, sure.
Does
It
it
makes
make
sense.
sense to
Makes
that
sense.
point?
Makes sense. It
Okay.
makes sense.
So I don't know if I should see if I can get it to look a better way instead of just using SPE and characters. Let me actually make it more valid. Let me see if I can make it more valid. Okay. So if you see up here, I have a struct and I have an array of those structs from line 1 to 13. I don't know if you can see that. Can you see that?
Yes, I can see the struct. I
So
can
yes. So
see.
instead of me going through all C, so I'm just going to delete this real quick. I'm just going to delete this. I'll make my check SP return a struct, a pointer to a struct. Yeah. Or okay, let's make it return a pointer to this function. Oh, wait, give me a second. Give me a second. You've learned about type dates, right?
Yes, yes, yes.
Type
To
dates. Okay,
to
so
rename
you can
the
see this
struct.
function inside this. Yes, so you can see this function inside this specifier struct.
Yes, I can see it. The
Yes.
function
So
pointer. You
I'm
mean?
just going to yes, exactly. I'm just going to create a type def for that function pointer. I'm just going to call it specifier function. So let me just take out this line. So it's easier to call it and return it instead of having to type in the whole function pointer again. I don't know if you understand what I'm saying.
Yes, yes.
Yes. Okay. So let me just quickly create and call that SPE funcs just as a type def. So now our check SP will now be returning those function pointers depending on the character that it sees. I don't know if this is making sense yet.
Yes, it makes sense.
It's making sense. Good. So now we have so instead of now looping through this all C array, I will loop through all SPE array. Can you see that array in line 10 of my file?
Yes, yes.
Yes. Now I'll go through that array and I'll be checking instead of now going through the way I'm checking like it was a like it was a regular array. I'll be
Was it?
checking. I'll
Was it?
now be checking it like a struct.
Okay.
Yes. So give me a second. So all sp.c. This is how you get the variables inside the struct. So for I equals to 0, I'll just be checking that all sp.c is not a null byte, which is the last
In
value
the
in
array.
that array. Exactly. So if I eventually find a character that matches one of the characters in that array of struct, I'll return the function pointer. So for
Pointer.
example, if I find a C, I want to return print char wrapper, right?
Okay.
Exactly. So that will be,
Okay.
give me
Okay.
a second, let me just edit this out, all sp.c. So I return all underscore spe.f. But this should actually, there should actually be an index here. I don't know if you notice that there should be an index here because I'm looping to an array.
Array.
So I should be
Yeah.
moving through the array of structures exactly. So now, if I see a character in that array of structures that matches the character that I was given, I want to return the function that corresponds to that character.
Yeah.
Does that make sense? Yes.
Yeah.
So if I
Yeah. Makes
don't
sense.
see that, I just return a null pointer. So now going back to my to my um to my printf
Printf.
implementation. So I'm just going to disobey Betty's rules. I'm very sorry. Please don't hold it against me. I'm just going to declare the variable here and initialize it here. I'll call it to be a variable that will be taking in that will be accepting sp funcs from line 7. You know, we are returning the function pointer. So I'm
Yeah.
going to use this my type def here to declare that variable down there that will be getting the return value. So I'll call that sp funcs. Oh, let me just declare it up here so it doesn't cause any confusion. Sp underscore funcs, then sp return value. So I declare that up here, and so this sp underscore return value will now contain the function that will handle the current specifier you're on,
Okay.
or the function pointer. Let me say that better. A function pointer that will handle the current specifier, or if that specifier does not exist or is invalid, it will just contain a null pointer.
Okay.
Yeah, exactly. So if sp underscore return value, so we're just checking that it is not equal to null.
Null.
Exactly. So we'll not get that value now, and then we pass in our variadic list. We're now passing our args, this value here that we declared up here, we'll now pass it in to our return value. If you notice that from the type def I created up here, you see that the type def is a function pointer. It's a type def for a function pointer that takes in a values as arguments and returns a string from line 7. Can you see that in line 7?
Yeah.
Exactly. So if we find out that the format specifier that we are on currently is valid, we'll just pass in the values, and then that function will just handle that particular character and the values that comes with it. Does that make sense? Now, does it make sense now? The splitting of the function. So instead of you having multiple if else, you just use one function to determine if the character is valid, and you also use that same function to return a function
Function.
pointer that will handle that particular specifier.
Yeah. Yeah. Yeah.
So
Yeah.
is it kind of clear now?
Yeah.
Does the idea make sense to you?
Yeah. Yeah. It really makes sense.
Okay,
If,
okay,
can
okay.
I get a screenshot of this whole page like this? Just this whole page. I just need.
Mr. Martin, you can confirm that this is being live streamed, right? Mr. Martin? Sorry, Martin, are you there?
Yes, yes. It's been live
Yes,
streamed.
so Mr. Kudus, it is live streamed, so we can send you the link after the session. You can always go through it again. It's no
Okay.
problem.
Boy, will it be?
Yeah.
Will it be on the group or?
Yes, I'll link it with the session info. Yes, I'll link it there. It will be under there.
Okay. Okay. Okay.
Yeah,
That's
sure.
good. Thanks.
Okay, no problem.
Mr. Jackson raised his hand.
Yeah, Mr. Jackson. Yeah, I saw you wanted to ask a question.
Yes, yes. Thank you for your time. For me,
Okay, you're welcome.
I am a little bit lost. Maybe if I can share my screen to show the progress where I'm lost.
Okay, you can go ahead. You can share your screen. That's why we're here.
Okay, okay.
Yeah, okay, so I'm going to leave the call now. So I'll just be, I will expect the recording. So thanks a lot.
Okay, no
Thanks a
problem.
lot.
No problem. You're welcome.
Yeah.
All right, no.
You can see my screen, eh?
Yes, I can see your screen.
Okay, now after I learn my check these errors I'm getting and
Okay.
trying to debug, I have this was let me go back a bit. This is the when I tried to look for errors, so I decided to Betty all my files. So and I happened to see that this underscore print f.c Betty was not happy about it. So this was the message. See?
Okay.
So so when I can show you my because I get the fact that I'm supposed to use call one function, but how to integrate it, I just wanted to like an overview, like an eye opener. Now let me set numbers.
You can
Now this is
actually add
my
this set number to your vim.rc so that you don't have to do this every time.
Vim dot.
Vim.rc, something like that. You can just browse it, how to make set number or any code you want to use on your Vim to be consistent.
Okay, I'll check about it. Okay, now this is my underscore printf.c. So somewhere I understand somewhere from line 25 I can somewhere instead of using this else if and make it be in one file. Now I wanted like an insight so that I'm able to understand that much better.
Okay. So basically, from what I'm seeing, your printf only handles C, S, and percent for now, right?
Like yeah, I was trying to solve for task zero before when I understand task
Moving.
zero, I will be able to move forward.
Okay. Yes, I
So
understand.
just trying to do
Okay.
something that I am understanding. Yeah,
Okay. So you just use if you check if it's if it's C or if it's S or if it's percentage. So that's the part you need
yeah,
to abstract away, so your function will be too long. Correct? That's if I understand
yeah,
you.
yeah,
Okay.
yeah.
So
Yeah.
okay, that's basically what I've been explaining. But let's just run it through again. Now you have
Okay.
your for loop. Okay, you have a while loop here, more or less the same thing. But okay, let me just be consistent. Let me take out the for loop I have. Let me use the while loop so that it just looks the same. You have your while loop that goes through the format specifier until it gets to the null byte, right? I mean the format string,
Yeah,
formatted
yeah,
string, until it gets to the
yeah,
null byte. And now you check that your format, if it's a percentage, if the current character you're on is a percentage,
yeah,
and then you want to know what is after that percentage sign.
yes,
Now, this is where the abstraction basically starts at. Now,
Uh-huh.
if you check, if you can see this function I created here on line 18, I called it check SP. It takes in a character
On your let me
on my
see.
screen here. Can you see my screen?
Let me go back there.
Oh, okay.
Okay, okay. Yeah, yeah. Now I'm on your screen.
Oh, you can't.
On
Okay, so you can see on line 18, I have a function there called check SP.
on line 18.
Yes, line 18 of my file. Can you see that?
Is this the same screen I'm seeing you're sharing? On line 18
Give me a say.
specs
Yes,
functions.
line 18.
Yeah,
Yes,
yeah, yeah.
yes.
Yeah, I
It's a
see it.
function
Yes.
called check SP, but
Uh-huh.
it returns a function pointer called SPE funcs. If you can see that function pointer on line 7, just confirm that you understand how that function pointer works.
On line 7.
Yes, on line 7.
Mhm.
Do you understand how that function pointer works? The lines. Do you understand what line 7 does?
I don't really get it.
Okay, okay. Can you see line 4?
Line 4, yes.
Yes, okay. So you see that that's a function pointer, which takes a
Yes.
pointer to
Uh-huh.
a function that takes in a var list and returns a string, right? That
Yeah,
much makes
yeah.
sense. Yes.
Yes,
So
yes.
basically, line 7 just creates a type def for that function pointer.
Or
You
the
you you
list,
you've, you've
the
used
spec
type def, right?
underscore FN. Uh-huh.
Yes. So line 7 basically creates a type def for that function pointer on line 4. It just kind
Uh-huh.
of makes it easier to
Uh-huh.
work with that function pointer. That's basically what line 7 does.
Mm-hmm.
So instead of me to have to type out the whole char star star f var list, I just type in sp funct whenever I want to refer to that particular type of function. You understand?
Yeah. Uh-huh. Now
Okay,
I get it now.
good.
Uh-huh.
Okay,
Uh-huh.
good. So now going back to line 18, you see I have a function there that takes in a
Then
character and returns.
a
Okay,
question,
okay,
sorry,
I can,
sorry, a question
okay,
before you proceed. On
okay,
line 5, why would you
okay.
not use the spec underscore FN and use it in line 7? Why did you not use the new name for your struct?
You see that spec underscore fn is just a type there for my struct.
A type def.
I don't know if
Uh-huh.
you noticed. That's the type there for my. That's the name of the type there for my struct. You see,
Yeah,
I
yeah,
created a
yeah,
struct up here, and instead of having, normally if you wanted to use a struct without a type def, if you wanted to use a struct, okay, let me
yeah.
take it back a bit. Let me go back a bit. If I wanted to use a struct normally, I will have to specify the name of the struct up here. Maybe I call it specifier, and then each time I wanted to use that struct, I had to first of all type the keyword struct specifier. You
Okay.
understand? Before I can
Yes.
then maybe assign, I can call the specifier, maybe I can call it fr, and then I can assign values to that specifier. Maybe I can put c here, and I can put a function here.
Okay.
That's normally how I would assign, I would use struct that I created. But when I use a type def, which is what I did,
Uh-huh.
I do not have to call the struct keyword each time I want to reference my struct. I will just call in,
Okay.
I will just call this maybe c underscore spe, and that will automatically reference the struct that I had previously created. So basically, a type
All
def
right.
just creates a new type for you
Okay.
and then
I
gives it a
see.
name. Just like how you have int and float and char, a type def just creates a new type and gives it a name, which you can always use as maybe an argument or declare a variable or return from a function. That's what a type def does for you, basically. So each time I
I
wanted to
get
call
it
my
now.
struct, you get that part now, right?
Yeah, I get that part now.
Okay, okay. So now going back to line okay, now is line 19 or 18. You see I have a function
Yeah.
called check sp that takes in a
Yeah.
character and returns sp funcs, where sp funcs is just my function pointer.
Yeah.
Can you see that? Yes. So you
Yes.
see that in
Yes.
my printf function, just like how yours is, I'll loop through the format. I check if it's a percent. And then if I see a percent, I want to go to the next character. Yeah. And then get I'll use the check SP function to extract what that character, to take that character. Oh, give me a second. You just give me a second. I just go ahead in the format string, and you see that will be a character. If you just do this format plus plus, that will just give you a single character.
Yeah.
And that single character is what gets passed into this check underscore SP function, which is the way the function
Okay.
was declared. It takes in a character and returns the function pointer. And
Okay.
then
Yeah.
I just store the return value inside this variable I created up here.
Oh, the spec. Okay. Okay. Okay.
You can see the variable, I declared that variable in line 36. It's a variable that stores a function pointer. You can see I just use my type def here. Instead of having to type in the whole function pointer, I just use my type def. You understand?
Okay. Yeah.
Good.
Yes, I understand.
So when the
That's good.
function, so now we go back to the check SP function. So when it takes in that character, it just creates a for loop, and then that for loop loops through an array I have already defined. Now look at this array up here. Can you see this array up here?
On line 11.
Yes, on line 11. Yeah, exactly.
Yeah.
So this is basically an array of structs. If you can see that, it's an array of structs. Can you see that it's an array of structs? Where the struct is just
Yeah. Yeah.
basically that struct I declared from line 1 to 5. That's the array of the struct
Yeah.
here. Now that struct
Okay.
basically contains a character and a function pointer that associates to that character, where the character is a specifier. You can see I have C,
Okay.
and for that C, I have
Yeah.
print char wrapper. I have D,
Yeah.
I
Yeah.
have a
Yeah.
function called handle decimal, and I have a function called handle decimal. So now I loop through that array on line 22.
Okay.
I check the C variable, which is basically the variable I called it in my struct, the C variable. I continue looping until that variable is a null byte. That's I've gotten to the end of my array.
Okay. Can you remind me what is the meaning of this dot C when you call
Okay,
the
that's just
array all?
okay.
Yes.
So basically, all SP like this is just me looping through the array, right? Array of structs.
Yeah. 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 Yeah.
Now, dot C is just basically how I reference those variables I declared previously in my struct. You can see for my struct, I have char C and I have a function pointer there. So that C
I
there is
see.
what I'm trying to reference.
Okay.
Can you see that on line 3? If you can see line 3.
Yeah. Yeah. Line 3. Oh.
Yes.
Oh, that
Okay,
character because of that. Okay.
yes, exactly.
Okay.
Let me
I
see if I
see.
can make it more specific so it makes sense. Let me call that char specifier. So it makes more sense. It's more specific. Yeah, so when I come here now, I have to reference the name of that variable in my struct with this dot notation.
Okay.
You
I get
remember it's
it.
a dot notation because I'm looping through the struct directly. If it was a pointer to the struct, I'll have to use this other notation, the dash and the angle brackets. But since I'm just looping through the struct directly, I just use a dot like this.
Okay. Yeah.
Yeah. So I
I
loop
get
through
it.
the
I get
array
it.
exactly until I
Mhm.
see an array struct that has a null character, which is the end of
Numbers.
my array, which
Oh,
tells me
no.
that's the end of my array.
Okay. Okay.
So if I see a character that matches the one that was passed into check SP, I return the function that corresponds to that character.
Yeah. Yeah.
Can you see that? So you see I return
Yes.
all underscore spi.f, which is the function that corresponds
Yes.
to that character. But if I
Yes.
loop through if I go through my for loop and I don't see any function like that, I just return a null byte. So that's
I
just
get it.
like that null byte would just be like how you have in your own if else, the final else block there. That null byte will probably just correspond to your final else block, if you
So a
understand.
question. Yeah.
Okay, I'm listening.
A question. When I write my underscore printf dot c,
Okay.
will it go up to line 30, or is it a must that I include from what is this part from line 33 doing?
Okay, from line 33, right?
Is it in the same file also? In
It
the
can be in the
same.
same file, it can be in a separate file. It doesn't, as long as you don't have more than 5 functions in a file. That's just the limit.
Oh, okay, okay,
But
okay,
this
okay.
underscore printf
So,
is preferred that you just put it in a separate file. That's more better to see, just to make it easier to work with.
so, this line that three is the second function in your file, for
Exactly. Line
example.
33 is the second function. Exactly.
Okay, 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 okay.
Yeah.
Mhm.
That's precisely what line 33
Okay,
is, the second function. So as long as you don't exceed 5 functions in a file and you don't exceed 40 lines per function, you won't have much of
mhm.
an issue with Betty.
Okay, 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 okay. I see it
Yes.
now.
And this method
So,
will just basically, yeah.
uh-huh. Okay, continue, continue.
Yeah, so this method just basically abstracts away having to use all those multiple if else else if blocks, and to substantially reduce the number of lines you have to write for each function, because you have a separate function that handles it, that handles that whole if else block.
Okay, so like
Does that make sense?
go.
Okay.
So yeah, yeah. So like, can you go down below what is like
Okay.
below line 56?
Okay.
Go, yeah. Again, again,
That was
again.
me trying to
So,
explain a wrapper
uh,
function.
okay. So, like for example,
Okay.
if I did not want to put this function print car lapper in this file, I want to put it in another file. How will this print
The char wrapper.
printf.c? Yeah. How will
I don't know. I think your
if
line is
this
breaking. I
function?
didn't get that.
No, he
I'm
said if
saying,
he wants to abstract print star wrapper into another file, how can he call the file? How can he call this function
yeah,
inside here?
Okay, if you wanted to put this in
yeah,
another file. Okay,
yeah, in
okay.
another
So
file.
let me
So,
just okay, let
so
me just take this out of this
No, no, actually you should just say
entire
it because
file
we are out
and
of
create
time.
yeah,
the running up, right? Okay.
Yes.
Okay, so you just create, let's just say you create a new file. This is the function
yeah, yeah. This is
here,
the
this is a new
function that you
file.
want.
Create that this
Yeah,
function now. You just take another prototype and then you create
uh-huh,
a main.h file
uh-huh,
or whatever
uh-huh.
printf.h file. I'm using Vim
Okay,
shortcut. Function prototype will be in your header
yeah,
file. So is just include that printf.h file in every single file you have for your entire functions. So I'll just include it here. Include, give me a second, printf.h. Do you understand this,
so with
Mr.
that,
Jackson?
my file. Uh-huh.
Yeah, Mr. Anthony, your line is actually breaking.
Okay, my line is breaking. Can you? Is it better now, or is it still
So,
breaking?
It's better
so,
now.
so, by including that, the hash include printf.h in our new file, in our printf.c, we'll be able to see that function. Eh?
Yes, and also in
Yes.
your printf.c file.
Okay. Okay.
Okay,
Now
guys.
I
Example,
think
in
my
all your
question is
files.
answered. Yeah. Yeah.
Okay, thank you very much. I think
Yes.
we've run
Okay.
out of time actually. Not even we're running out of.
Okay.
And there's actually another session that has
Oh,
started.
okay. Okay.
I think it's
Thank
the
you very
last
much,
session
Martin,
for
for
today.
calling me.
Another session just started. I think it's the last session for today. So you can still join that if you have any question. Please, there's
Okay.
a link in the chat before you leave to help us fill the feedback form. It's required for us to show you the feedback form. So you just help us fill it before you leave. Thank you very much.
Who are